So now I'm going to go over how to do number 4 on the conservation of energy and work exam. In this question, we have a block that starts at a height of 3.1 meters from the ground, and it's on a perfectly round ramp. It's 3.1 meters high. We have the round ramp is frictionless, and the flat part is not frictionless. And I have the coefficient of kinetic friction is going to be 0.71. And I want to know this distance, capital D, before it comes to rest. So I'm going to remember the work and energy, and I'm going to go ahead and do a bar chart for it. So at the beginning, I have gravitational potential energy because it's up in the air at 3.1 meters. My kinetic energy is 0. And then really you can think of this as before, and then this middle part here, this is during. So whatever's happening. And then this is how much energy there is after. But in terms of your equation, we need the equation sign, the equal sign, to go between during and after. So that's why a lot of times you'll see me not put this set of dotted lines in. And so this is the work done on your system. Specifically, my work is going to need to be negative because after the block slides on this friction thing, then there is work done from friction to remove energies from the system. So that's why I made work negative, because after that, my gravitational potential energy will be 0. And my kinetic energy will also be 0. So now I have a setup for me to go ahead and write my equation. So I have gravitational potential energy, which is mgh. Kinetic energy is 0. Work done is going to be my force, which in this case is frictional force. And the distance that's parallel to it, so friction, it will be horizontal. The distance that I'm traveling is also horizontal. So that distance is d, that's what I'm looking for. And then that'll be equal to my gravitational potential energy, which is 0, plus my kinetic energy, that is 0. All right, so I just now need to plug in all of the numbers. And I realize, oh man, I don't actually have my mass. But I remember that in this case, when my block is sitting here on the ramp or sliding on the ramp, the only forces acting on it is gravitational force, normal force, and frictional force. And so in the y direction here, my normal force is what's going up, my gravitational force is going down, and the acceleration in the y direction is 0. So this then is going to be equal to 0. And because of that, I know my normal force is equal to gravitational force, and that is mg. So instead of my normal force, I'm going to plug in here mg. I'm going to leave the coefficient of friction, distance here, mass, g, and 3.1. That's my height. All right. Now I'm going to divide everything by mass because everything has mass in it, or it's a 0. And I can do the same thing with g. And the coefficient of friction is 0.71. And the distance is what I'm solving for. Bring this over here. Now, one of the things that I want to point out here is that I did this with a plus for my work. But in this case, I want to make this actually a minus because the force is going to be going to the left. And so when I figure out that frictional force, I need to remember that it's going to be a negative. And since I'm always using forces as positives, I'm going to put this as a minus just so that I remember. And you can do the same thing because it is going to remove energy from the system. And what that means is then when I get to this point here, I can then add the 0.71 d to both sides. And I get 4.366 meters is the distance that it'll travel before it stops. If you have any questions, let me know.